for CIS566, I chose the composite pattern. The intent of the composite pattern is to compose objects into tree-like structures to represent part-whole hierarchies. These part-whole hierarchies let the client treat the groups and the individuals uniformly. The groups within the hierarchy are the composites, while the individuals are the leaves. A lot of the information in this PowerPoint has been gathered from Design Patterns, Elements of Reusable Object-Oriented Software by the Gang of Four. The composite design pattern is applicable when there is a need to show part-whole hierarchy of objects, as well as when you want to treat all of these objects uniformly. For example, in the file system, both file and folder should be treated similarly. Both will have many overlapping methods, but will enact those methods differently. A method like open would open the folder, a composite of files, by making all of the files visible to be acted upon, while calling open on the file will open the file in the application of choice. The motivation comes from when using many similar objects to avoid using them differently, we enact the composite pattern to treat all objects uniformly. This would allow for a simple open all call on Tom, the top folder, for all files and file types within to be opened. This would happen by going over the stored lists and all composite objects that are children to the Tom folder. The structure of the composite pattern is a simple tree made up of 4 different classes: the component class, the composite class, the leaf class, and the client class. As seen above, the component acts as the interface for both the leaf and the component. The participants are the components, which is the default interface for all the objects, composites, and leaves, as well as declares the methods shared by all the objects. The composite defines behavior for components having children. These hold the leaves, as well as implement child-related methods, such as add, remove, or get child. Leaf has no children and defines the behaviors for itself. This would be acting upon the operation, as seen in the composite class and in the leaf class. The consequences. There's some consequences for the composite pattern. These consequences include mistaking a leaf object for a composite or a composite for a leaf. This can lead to developer confusion. The simple client class does not help solve these differences either. Since it is easier to add new types, it is also easier to mess up those components, and it is harder to restrict those for new leaves. There's many ways it can be used. Other than the file system, it can be used to show teams or hierarchy. The first example is the sales team example. The composite class is the sales team, while the leaves are the individual salespeople. Both the composite and the leaf use the sales interface and enact the same methods. The team enacts the methods over each of the people within its team, and person executes the method by returning personal status. In this example, there has been an added method, report MVP. In the sales team class, it iterates over each member of the team, comparing who has the best profit margin, which is using the get profit minus the get cost. This allows for the MVP to get recognition. A more in-depth composite or example of the composite pattern is a tree that has composites below an initial or at a similar level to another composite. So here, the principal, the math teacher, and the science teacher are all composites, while the leaves are the janitor, the TA, and the student teacher. The component class for this example would be the interfaces, people, secondary teacher, and teacher. While there is not currently actions for the teacher or secondary teacher now, allowing for an extended interface gives an opportunity to give more specific methods to be used by the composites of this interface in the future. These lower level methods would not need to be known by the higher parent, but would be used by their composites. In this example, teacher could have a new function for show students. This function would not need to be added to the principal class, but could be obtained by a simple function, getAllClasses, which would use the new method and its personal list of teachers to find out all the students in each class. The composite classes are the principal, the math teacher, and the science teacher. In the composite classes, there's a list and a string identifier. These classes contain the operations which for this example of showing hierarchy are just get direct leaves and get all leaves. These operations are designed to show the hierarchy of the school. A performed job method would be another operation that would apply, but to keep code denser, we are focusing on the hierarchy. The methods in this composite class loop through all of their children and perform the necessary methods to achieve what is desired. For getting the direct leaves, all that needs to be done is to get the names of the leaves, while getting all leaves, we'll call getAllLeaves function on all of its children. Similarly, there should be an add leaf, remove leaf, and if necessary, a get child. These are shown by add subordinate, add secondary teacher, remove subordinate, and remove secondary teacher. The get child has not been implemented, but it can be implemented by using a getter with people as the input or with an integer number as the input, and getting the values out of the stored array list within each of the composite classes. The leaf classes are the janitor, the TA, and the student teacher. These are the leafs, so they have no arrays of objects. When calling the operation on the leaf, it needs to let the parent know its status. Since the leaves are the end of the tree diagram, they let the composites know that they are currently the leaf. Again, with these classes, a do-job operation would result in a specific job for that individual object. So for a do-job in student-teacher, it would be highly different than a do-job within janitor. Since the operation of this example is to show the position in the tree, we have a similar response, while in the future, when the software has expanded, there would be many operations that all leaves have in common, but enact vastly differently. The client class is made to stay simple. Most of the code is just creating the objects that are to be placed within the hierarchy. Above shows both the client class for the sales example from earlier and the client class for the school. The below output is the result of the print statements within the functions. The client class can be kept very simple by moving the building of teams and people into functions and returning the composite object. Here, the principal, math teacher, science teacher, student teacher, TA, and janitor are all created. The principal then gets the math teacher and science teacher added to its array list, as well as the janitor. Then, the math teacher needs to add its student teacher, as well as the secondary teacher that is helping out. The science teacher then adds their secondary teacher. One call on the principal to get direct leaves will result in only the teachers and janitors assigned to the principal, while getting all of the leaves will result in printing of everyone, as seen at the bottom. Similarly, for the sales example, everyone is added to their respective team. By calling the composite methods on the team, you can show how it can easily simplify the code. Instead of calling those functions on each individual, we can just call it on the composite object, which will return the composite of all of the individual leaves within. Here, it is a good way to measure team success as well as individual success. And by using these methods, it creates very simple client code. By removing these initializations into a function, the client main method can just be a simple call to these static functions. That is the composite design pattern. Again, I use design patterns elements of reusable object-oriented oriented software by the Gang of Four to get a lot of the information, and the examples are simple ways I thought I could show the pattern. Thanks for listening.